Hi again, welcome to the video on differentiating with the chain rule. In this video we develop the technique of forming a gradient function using 5 short steps to differentiate a function enclosed in brackets which are in turn raised to a power. We can differentiate functions in many different ways. Recalling the way we did simple differentiation, the function y equals x cubed plus 5x squared plus 42 differentiates to dy dx equals 3x squared plus 10x, and we get this result by differentiating one term at a time. The methods used to differentiate depend on the structure of the function we are addressing and the nature of the components in it. So therefore, when we are going to differentiate, the first step we always follow is to look at the structure. One of the most important strategies of the technique of differentiation, or finding a gradient function, is referred to as the chain rule. The structure of the original function for which the chain rule is used is characterized by a single bracketed term containing a function, and that term is in turn raised to a power to create a larger function. A typical example of this structure is fx equals 3x plus 4 in brackets all to the fifth. So our first single bracketed term is the 3x plus 4, and when we raise it to the fifth power, we're creating this larger function. We will talk through 4 examples now to demonstrate how to dance through the 5 steps in order to implement the rule. We'll take the same example, fx equals 3x plus 4 all to the fifth. So step 1, bring down the index to the front of the brackets. So we'll write f dash x equals 5. Rewrite the terms in the original brackets, so bracket 3x plus 4. Take 1 off the index, so we have a 5 minus 1 for the index, which of course is 4. Multiply these brackets that we've got there by the derivative of what's inside the brackets. So we have 3x plus 4 inside the brackets, the derivative of that is just 3, and then tidy up and make the result look beautiful. So f dash x is equal to 5 bracket 3x plus 4 to the fourth times 3, and 3 times 5 is 15, so we have 15 3x plus 4 to the fourth. So nice. So good, so quick. Example 2. We have to differentiate fx equals 2 outside of 7 minus 3x squared, all raised to the sixth. Now, the steps are exactly the same, and to emphasise that, I've just left the steps there from what we had in example 1. So, we start. The 2 out the front is just a decoration. It serves no real purpose, just like an earring. So put the 2 down. Now bring the 6 down from the index to the front, so it's 2 times 6. Second step, rewrite the brackets. We have 2 times 6 and bracket 7 minus 3x squared, end bracket. Take 1 off the index was 6, so it becomes a 5. Then multiply by the derivative of what's inside the brackets. Derivative of 7 is 0. Derivative of minus 3x squared is minus 6x, and now tidy it up. So f dash x is equal to 2 times 6 times minus 6, which is minus 72, x bracket 7 minus 3x squared all to the fifth. So good. Next example, and we will do nothing different about our 5 steps, so we leave them there. Here, the format looks a little bit different because we've got the bracketed term underneath, but we can fix that easily because we just bring it up and use a negative index. So it's 3 outside of 3x plus 4 all to the minus 2. So we've got a 3 there and there, decoration, put it down, bring down the minus 2, so we've got 3 times minus 2, rewrite the brackets, which is 3x plus 4, there it is. Then take 1 off the index. Now careful, the index is presently minus 2. We take 1 off, it becomes a minus 3. We then multiply by what's inside the derivative. Derivative of 3x is 3 and the 4 is location constant, so it disappears. So we now tidy up. 3 times minus 2 is minus 6, times 3 is minus 18, times 3x plus 4 to the minus 3, which we'll write straight away as minus 18 over 3x plus 4 all cubed. Fourth example, here we use a radical, the square root. So y is equal to the square root of 3 minus 2x. Change it around so we've got it an index, so it's 3 minus 2x all to the half. It's exactly the same format, so it's going to be exactly the same steps. First step, bring the half down the front. Second, rewrite the bracket, so bracket 3 minus 2x. Take 1 off the half, so it becomes a minus a half. Then multiply by the derivative of what's inside the brackets. The derivative of 3 is 0, the derivative of minus 2x is minus 2. Now tidy it up. We've got a half times minus 2, so they cancel out, leaving us with a negative 1. And the negative index is take the radical and put it underneath, so it's minus 1 over the square root of 3 minus 2x. Always the same, always a beautiful way of getting a good result. So after 4 examples, we can do a summary, and therefore our steps can slowly fade away. We use the chain rule technique when we have one bracketed term and that term is raised to a power. We always follow the rhythm of bringing the index down to the front, rewriting the brackets, taking 1 off the index, multiplying by the derivative of what is inside the brackets, and then of course tidying up. The same process of the chain rule will also be used with exactly the same rhythm when we come to using calculus with exponential, logarithmic and trigonometric functions. It's easy to be good at it, and that's where I want you to be. Really, really good. Hope you now understand the technique for using the chain rule and you feel confident in using the 5 steps to determine a gradient function. Thanks for watching this video. The next 2 videos explain the use of the product rule and the quotient rule for differentiating different formats for functions. Hit the like button and subscribe if you haven't already. Also go and do some questions on the chain rule, Test Yourself 1, on my website at drjaysmaths.com. Add a comment below and send me an email if you have any questions. Good luck. See you in the product rule.